The broadcast is now starting. All attendees are in listen-only mode.
Thank you, Jason. Today I will talk about the sense and nonsense of alarm management KPIs and how these have been changed between different standards. First of all, what is a KPI? It's a key performance indicator, which is a set of values that serve as a benchmark to verify how well or how bad your alarm system is performing. Note that the performance of your alarm system has little to do with how your operators will use it, but everything with how it is conceived and configured. A poorly conceived alarm system will generate too many alarms, most likely with the wrong priorities, and will overload or stress the operators using it. So where does these KPIs come from? KPIs stem from a survey performed in the UK in the 90s in 40 continuous process plants, where the operators were asked what would be acceptable as a long-term average alarm rate in steady operation. The survey indicated that more than one alarm per minute was very likely to be unacceptable. One alarm per 2 minutes was likely to be over-demanding. One alarm per 5 minutes could be manageable, and less than one alarm per 10 minutes was very likely to be acceptable. So these figures made it to the first edition of the EMUA 191 publication, which is a guideline on alarm systems, and they have made it until the third edition, which was released in 2013. And there is a table in that edition that says that more than one alarm per minute in steady operation is very likely to be unacceptable. 1 per 2 minutes on steady operation is likely to be over-demanding. 1 alarm per 5 minutes could be manageable, and less than 1 alarm per 10 minutes is very likely to be acceptable. So being part of EMUA 191, it has also made it to the first edition of the ISA 18.2 standard on alarm systems. In that first edition, you will find in figure 14 an alarm performance metrics summary, which indicates that the enunciated alarms per day per operating positions would be very likely to be acceptable at the rate of 150 alarms per day, and the maximum manageable rate at 300 alarms per day. The enunciated alarms per hour per operating position would be very likely to be acceptable at 6 on average, and maximum manageable at 12 on average. Or, in other words, the enunciated alarms per 10 minutes per operating position would be very likely to be acceptable to be 1, and maximum manageable to be 2. You see there's already a slight difference between the survey performed in the 90s and how it is presented in this table. Now, when IEC 62682 took the ISA 18.2 standard and they looked at the table and they figured out that the maths were not done properly, because 6 times 24 is 144. So they said in their table the enunciated alarms per day per operator console is very likely to be acceptable at 144 alarms per day, and maximum manageable at 288 alarms per day. Or in other words, the enunciated alarms per hour per operating console would be very likely to be acceptable at 6 per hour, or maximum manageable at 12 per hour on average, which stems from the original enunciated alarms per 10 minutes per operating console being very likely to be acceptable at 1 alarm per 10 minutes and maximum manageable at 2 alarms per minute. Now, when the ISA 18.2 committee gathered again after the IEC 62682 was released in 2015, we found that table a bit outdated. Progressing insights and the calculation of 1 per 10 minutes to 6 per hour on average and 144 per day on average was considered to be a bit odd. So, in the ISA 18.2 2016 edition, a number of these KPIs were omitted. The 144 alarms per day were omitted. The unauthorized alarm suppression KPIs were omitted from the table, and the percentage of hours containing more than 30 alarms were omitted. So this webinar will discuss a bit why these were omitted and what the danger is of averaging out less than 1 alarm per 10 minutes to be very likely to be acceptable, to 144 alarms per day being omitted from the key performance table. So, 1 alarm per 10 minutes per operator is very likely to be acceptable on a number of conditions. The first condition is that the operator is not performing another task. For instance, dealing with another alarm. The operator is able to acknowledge that he will deal with the situation in a reasonable amount of time, meaning he is not doing something else and he has enough time to perform the actions. Well, talking about actions, the actions that the operator has to take will cost less than 10 minutes of his time, right? And lastly, the consequence threshold, so the time between the operator acknowledging the alarm and the process or device or installation or machine reaching the next consequence should also be larger than 10 minutes. So let's take a look at this consequence threshold. So there was a figure published in IEC 62682 and ISA 18.2, which more or less looks like this. It presents a moving value process variable in time, and at a certain point, the alarm set point, it is alarmed. The next delay that is in this figure is the acknowledged delay. Basically, it's a time to take responsibility to deal with the alarm. The next delay in this figure is the operator response delay. That is the time the operator needs to think before starting actions and performing all the actions. The next delay or time frame in this picture is the process dead time. The process dead time is the time the process needs before any effect of the operator actions become imminent. And lastly, there is a process response time, so that's the time the process needs to return to its normal operating window and the alarm gets cleared. So, how much time has the operator actually? So, he has a limited amount of time, being the time between the initiation of alarms and the alarm consequence threshold, minus the acknowledged delay and the process dead time. This acknowledged delay has to be taken into account when conceiving an alarm system. For a situation where the operator is supposed to be in front of his desk with all the windows and monitors that are at his disposal, this acknowledged delay will be very short. I know of a plant where nobody is in the control room and the alarms are broadcasted over the PA system. So there the acknowledged delay needs to take into account the time that somebody walks into the control room and acknowledge he will take responsibility to deal with the alarm. I know of another plant where some of the alarms are sent by SMS services to the smartphone of the operator who might be remote. That can take minutes or hours even, if the person is not responding immediately. So this ACK delay should be taken into account when configuring the alarm. The other thing that needs to be taken into account is the process dead time. For fast processes, it can be very short. For other processes, it might take a reasonable amount of time. And when conceiving or configuring the alarm, it should also be considered what happens at the consequence threshold. Let's look at the actions the operator has to perform when the alarm system detects an abnormal process condition. The operator has to understand the current process conditions. He has to ascertain the future consequences. He has to investigate the root cause. He has to take actions to prevent effects from spreading. He might need to take actions to correct the current process conditions. And he might need to take actions to fix the underlying cause. And furthermore, he needs to monitor the outcome of these corrective actions. So aside from physical actions, the operator must perform a number of cognitive tasks, and he should be trained to perform all these tasks. But the engineer configuring the alarm system or the alarm should also be aware of these tasks. The alarm system and the HMI should be conceived in a way that the attention of the operator will be drawn to the situation that is alarmed. The different cognitive tasks should be taken into account when designing a task-oriented HMI. The alarm text should contain as much information as possible to assist the operator in taking the appropriate actions in the limited time frame available. That being said, we return to the danger of averaging. 1 alarm per 10 minutes equals 6 alarms per hour on average, that the annunciation or the appearance of the alarm is evenly distributed. That the response time on average to take actions on all the alarms take less than 10 minutes on each alarm. That the operator, when the alarm is annunciating, has nothing else to do. So, what will happen if the operator has 2 alarms in 10 minutes? He will probably switch to multitasking. Now, there are some dangers of multitasking. I want to elaborate a bit on this. Recent psychological and neurological studies have pointed out that multitasking is dangerous. It has been considered to be dangerous to telephone while you are driving a car, or even worse, that texting when you drive in the car is extremely dangerous. So why would we expose operators to similar risks? This is what happens if you switch tasks. Your brain has to mentally end task 1, move data from the working memory to the temporary memory in the brain. The brain has to clean the working memory. It has to get the data from the other tasks, from the temporary memory to the working memory, and the brain needs to rebuild focus. So, and that goes on and on when you switch between task 1 and task 2. So it has been pointed out by different studies that the time required to complete 2 tasks while task switching is larger than the sum of the time to complete task 1 plus the time to complete task 2. So it is recommended by psychologists and neurologists to do serial task completion and take a break. So if you would have 2 alarms with the same priority, the operator should deal with the first alarm first, then take a deep breath, and then deal with the other alarm. Other studies, among others from Professor Medina in the United States, have pointed out that task switching also has a negative impact on the degree of focus and attention. More errors are made when switching between tasks, both on numerical manipulations or letter manipulations. So dealing with more than one alarm at a time per operator should be avoided. And also from the psychology side, having to deal with more than one alarm at the same time induces stress at the operator and the fear of losing control. All these were good reasons to omit percentage of hours containing more than 30 alarms from the KPI table. This situation should actually never occur. But you also need a tool to analyze in detail whether or not there are situations where you have more than one alarm per 10 minutes. At first sight, this alarm system has less than 7 alarms per hour, but if you look at the detail, you see there are several situations where the operator has more than one alarm at the same time. And even worse in this case, 3 out of these were of the highest priority. So that being the alarms at the same and highest priority will force the operator to do multitasking. Now we have seen that one alarm per 10 minutes does not equal 6 alarms per hour. It's not because you can produce 10 hamburgers per hour that you can eat 6 hamburgers per hour, right? So if you consider that this is not very reasonable, then the further extrapolation of 6 alarms per hour to 144 alarms per day is even more nonsense. These 144 alarms on a daytime can fall all in 1 hour, in one shift. And furthermore, we don't want one operator to work 24 hours per day, right? The KPIs were defined for the operator, not to overload him. So, those were the reasons that the KPI of 144 alarms per day would be very likely to be acceptable was omitted from the table in ISO 18.2 revision 2016. So what is a good KPI? Well, it's not because a standard or guideline recommends KPIs that it should be your KPIs. There is no obligation whatsoever that your alarm system needs to comply with the recommended KPIs from the standard. Your average alarm rate KPI should depend on a number of other things. For instance, the type of process you're running, whether it's a continuous process or not. The involvement of the operator. Is he near the operator console or is he far away? Is he near the process or is he remote? I know of control rooms which are onshore, which monitor operations on the North Sea. Well, you can tell that the operator is there quite remote from the process or the installation he is monitoring. And furthermore, the average alarm rate depends also on the complexity and the duration of the actions that the operator needs to perform. In a complex plant, these can vary from very simple, changing a set point, to be very complex, having somebody go outside, perform a number of actions, and then see if the process responds to these. Another thing to take into account is how your alarm system is performing today. Because if you set your goals at a level that is perceived as unachievable, nobody is going to do an effort to achieve these average alarm rate KPI within a reasonable time frame. So what would be a reasonable KPI for the alarm rate per day? So if your alarm system today generates 1 alarm per minute, then 1 alarm per 2 minutes could be a reasonable KPI for your site. For the first year, you put an alarm philosophy in place. If your operators need on average 20 minutes to deal with an alarm, then one alarm per 20 minutes could be a reasonable KPI. And if your operators, for instance in a batch plant, are close to the process or the machine they operate and can deal with an alarm every 5 minutes, then it could be one alarm in 5 minutes. In other words, based on the operator response time estimated during the rationalization process, these KPIs should be set. But if you don't have an alarm philosophy, then any external audit would compare the performance of your alarm systems with the KPIs listed in the standards and guidelines. That was on the average alarm rate. There was another item being omitted from the KPIs, which are the two items actually, which are the unauthorized suppressions and the unauthorized alarm attribute changes, which are no longer KPIs. Some companies and industries allow operators to suppress or change. Where you have companies that do not authorize changes, they should put in place a procedure or a tool and not a KPI. So if you don't allow operators to suppress or change alarm attributes or alarm limits, then you should monitor these changes all the time. And how do you monitor it? You need to set up a master alarm database to see the deviations that have been entered against what you have set in your master alarm database as the right and appropriate alarm limit or alarm parameter for that alarm. So, unauthorized suppressions and unauthorized alarm attribute changes should be dealt with a procedure or a tool and not with a KPI. They are also subject of the management of change process. If you want to change an alarm attribute, then an appropriate procedure should be followed, and that should be managed as a change in your alarm system. So, as a conclusion, I would recommend that your alarm philosophy will set your alarm system KPIs, also the average alarm rate KPIs. Take into account that different operating modes can result in different KPIs or different sets of KPIs. If you are not in a continuous plant, and remember the survey was performed at 40 sites in UK, which were all continuous plants. So if you don't have a continuous operations 24/7, then you might have a set of KPIs for your production shifts and a set of KPIs when there is no production. It's important to choose a monitor and assessment tool that can deal with this, that can deal with the fact that you set your alarm KPI to something different than what is listed in the guideline. And consequently, you make sure that the reports allow you to analyze the rate you have set in your alarm philosophy, so you can do per 5 minutes analysis, per 10 minutes analysis, or per 20 minutes analysis. And lastly, and most importantly, the KPIs for your alarm system were created to measure the workload the alarm system imposes on your operators. So, make sure you have reasonable KPIs in your alarm philosophy. Thank you for your attention. If you have any questions, you can ask them now.